Hello, I'm Daniel and this is my final year project titled Customer Churn Prediction Web Application using an integrated machine learning model. This project was supervised by Mr. Tong Gee Kok and it will be moderated by Dr. Faha Amalia. Starting off with the introduction, retaining customers is an important aspect in today's competitive market and for any businesses seeking to maintain their customers and allocate resources efficiently. Predicting churn accurately can be a massive help to proactively retain the customer base by taking preventive actions. This project was done in order to build a machine learning integrated web application that can predict churn and at the same time also making it usable and understandable for non-technical business users. Moving on to the next slide, which is the problem statement. Essentially, the project addresses three main challenges. The first one is the class imbalance. Churners are often a small fraction of customers and thus it makes the dataset skewed. The next one is the overfitting issue. Models may perform well on training data but fail in a real-world use. Lastly is the lack of usability. Business users may struggle to understand the model outputs as they are presented in a very technical way. Regarding the problem statement, the objective of addressing such problems are number one is to improve model prediction capability, especially for the minority chain class by rectifying the class imbalance issue. Next is to enhance the generalization ability and also prevent overfitting via regularization and tuning. And lastly is to bridge the gap of usability by making the system interpretable and accessible to business users through an intuitive interface. This next slide is about the system design. The diagram shown is the overall architecture of the system. Basically, the back end is built with Python and Flux, hosting the trained models and APIs. Meanwhile, the front end is developed using React with role-based routing and JWT authentication. This system is developed to be modular, covering user management, prediction services, and model explanation. Moving on to the next slide, as you can see here, this diagram shows the flow of the ML pipeline. Starts with the data pre-processing which includes initial data inspection, data cleaning, and future engineering. Next, the pre-processed dataset is then split into 80-20 ratio, 80% for training and 20% for testing. We then train the base model, logistic regression, and random forest in order to get a baseline performance result. After that, we apply Edison and Tomac links for resampling purpose. And after that, we continue to improve the models with hyperparameter tuning. Later on, we further optimize the models by applying threshold to reduce cost and improve the recall. Finally, the best models are selected and imported using job-lib as they will be integrated into the web application. Now I'll be switching to my poster. Alright, let's quickly walk through the poster. We have introduction, abstract, problem statement, objective, literature review on the left side of the poster. The middle section shows the system design and research methodology. As I explained before, on the right side, we see the evaluation results. For instance, Tomac links with logistic regression achieve a recall of 75%, and threshold tuning helped reduce monthly misclassification losses from 51,600 ringgit to 39,150 ringgit. These findings support that combining resampling, model tuning, and interpretability tools can create a churn prediction system that is both accurate and practical for real-world use. The same system is also formalized in my research paper titled Machine Learning Application for Churn Prediction and Interpretability. Written in IEEE format, the paper is an 8-page condensed version of my FYP report. It presents a validated approach that effectively balances performance, cost sensitivity, and interpretability in the context of churn prediction for business application. Now let me show how the system works in action through a live demonstration. First, let me log in into the demo account. Let me clear the mock data. So basically, this is a view if you are a new user when you log into the application. As you can see, it's empty because there is no data registered yet. And again, let me fill up back the dashboard with mock data. And now, after the mock data has been inserted, we can see key stats like total number of customers, current churn rate, which is currently at 53%, and we can also see the average tenure and monthly charges. The churn rate trend shows the recent fluctuations, and you can also toggle between monthly, quarterly, and yearly. And on the right side, we can see the top churn factors bar chart that reveal the strong churn drivers, which is the currently the no tech support and month-to-month contract is the highest or the strongest churn drivers. Below, there are pie charts showing churn distribution by age and gender. And we also have a table of recent predictions with model type and churn probability. User can also download the data shown in the table in a CSV format by clicking this button. Lastly, the bottom section gives insightful recommendation for decision makers. Next, we go to the prediction page. So basically, the user starts by entering basic info like name, age, gender, and region. And after that, they can input service related details like tenure, monthly charges, and all that. So let me fill up the details real quick. And user can also choose between logistic regression and random forest with the built-in tip, so users know when to choose which model they are going to use. And after clicking the predict button, the system will process the details and it will present a new result here, a prediction result. As you can see, we presented with 68% of medium risk. And also it also come with the key churn factors and also retention strategies. So this page is designed to be simple and straightforward, making it effective for business decision making. Lastly, we have the model explanation page. This page helps users to understand better on how the model works. It starts with a summary of the selected model and its pipeline. And over here, we can see the future importance chart showing which futures push churn probability up or down. And then we see the performance metric over here. We got the accuracy, recall, precision, and endpoint score. Below that, the sharp value distribution give detailed interpretability for individual predictions. And finally, the model limitations are also listed to remind users that predictions depend on input quality and trade-off. So the user intervention is very crucial when the user are predicting. So back to the slide again. So conclusion and future work. In summary, this project delivers a practical churn prediction tool that is both accurate and interpretable. It improves recall, reduces churn-related costs, and at the same time empowers non-technical users through a friendly interface. There are several works that can be done for in future, like integrating multi-source or real-time datasets to improve generalizability and responsiveness. Next one is to explore more advanced models such as XGBoost for potentially higher predictive performance. Next, to develop a mobile version of the application to increase the accessibility. And lastly is to conduct a formal usability testing to gather structured feedback and refine the user interface. That concludes my presentation. Thank you for listening.